Let's welcome Professor Bonnie Bassler, Chair of the Selection Committee for the Shaw Prize in Life Science and Medicine, to tell us more about it. Professor Bassler is the Squibb Professor and Chair of the Department of Molecular Biology at Princeton University, USA, and also a 2015 Shaw Laureate. Hello, Professor Bassler. Nice to meet you.
Nice to meet you, Leon.
So we know that cystic fibrosis is an inherited disease that is life-threatening. But what causes it and how does it affect the body?
Cystic fibrosis, or CF, is one of the most common severe single-gene disorders, affecting more than 80,000 people globally. The single gene in which the disease-causing mutations fall is called CFTR, for cystic fibrosis transmembrane conductance regulator. The CFTR protein ensures the proper flow of chloride, a component of salt that is present in secreted body fluids such as sweat, saliva, and mucus. These fluids keep cells lubricated and are vital for the proper function of organs. In CF patients, these secretions become thick and sticky, and rather than acting as lubricants, clog passageways, especially in the lungs. The disease is fatal. There are many different mutations in CFTR that cause the disease, but a mutation called F508del is particularly important and is present in about 90% of patients.
Well, the identification of the CFTR gene and the disease-causing mutations is groundbreaking. And I believe this is where our 2022 laureates, Professor Michael Welsh and Dr. Paul Negulescu, step in.
You are right, Leon. Michael Welsh from the University of Iowa discovered that the CFTR protein is a chloride channel, and he revealed how its activity can be regulated. He corrected the CF defect in culture cells by providing a normal CFTR gene, thereby showing that correcting the defect was a feasible therapeutic strategy. In extraordinary studies, Welsh then demonstrated how different CF disease-causing mutations affect the CFTR protein. Some eliminated its production, some interfered with its trafficking to the cell membrane, and some prevented the opening or function of its chloride transporting channel. Welsh categorized the different human CF mutations according to mechanism, and he laid out a scheme to correct each type of underlying defect. Importantly, Welsh showed that the CFTR protein with the common F508del mutation has multiple defects. The protein did not reach the cell membrane and was also defective for chloride transport. Very crucially, Welsh discovered an experimental condition that enabled CFTR F508del protein to make it to the membrane. And he showed that when the protein did reach the membrane, it functioned.
Ah, I see. So that means if a therapeutic strategy could be developed to get CFTR F508del to the cell membrane, it would be beneficial in combating the disease?
That's correct. Welsh's discoveries provided the needed groundwork for Paul Negulescu from Vertex Pharmaceuticals to make the leap from mechanism to therapy. He and the Vertex team discovered small molecules to treat CF by embarking on an enormously risky strategy of screening for compounds that could fix a defective protein. Moreover, because there are many different CF-causing mutations, it was not clear that one medicine capable of treating the majority of CF patients could be developed. Negulescu first discovered a CFTR potentiator that stimulated CFTR channel function. This medicine, called Kalydeco, received breakthrough designation. However, Kalydeco was useful only for the subset of CF patients with certain rare mutations, not for the vast majority of CF patients with the CFTR F508del mutation. In an even more bold effort, Negulescu then screened for molecules that could correct the trafficking defect of the CFTR F508del protein. Remarkably, he discovered such a molecule, a protein corrector. He combined the new molecule with Kalydeco, now named Orkambi. He improved on Orkambi twice more, combining 2 protein correctors with the potentiator to make Trikafta, approved in 2019. Trikafta helps patients with the CFTR F508del mutation and patients with the 177 rare CF mutations. Currently, 50% of all CF patients take Vertex CF medicines. The combined contributions of Welsh and Negulescu represent the complete biomedical arc from basic discovery to application to the saving of lives. They are especially worthy of the Shaw Prize in Life Science and Medicine.
Thank you, Professor Bassler.